A research on development of induction oven for food delivery vehicles. Abstract: in this era of dynamic changes and cutthroat competition, to survive and to thrive, people are busy in earning like never before. They want to spend minimum time possible in doing things like cooking, traveling, house cleaning, which are necessary yet not priority. So they look for alternate less time-consuming options to get this chores done in a way that it has least effect on their working schedules. Eating healthy food and maintaining health is another aspect that cannot be compromised to keep up with the competition. So people look for food which, along with satisfying their taste buds, is healthy for their digestion system. As cooking quality food takes time, so being in generation which for the most problems of their lives, looks for a solution on internet, people started relying more upon food of hotels and their instant deliveries on their doorsteps, which turned out to be the primary reason of success for global food delivery brands like Uber Eats, Grubhub, Just Eat, Olo, Snapfinger and etc. They have established their centers worldwide and keep expanding their boundaries rapidly. We have visited some of them and we're talking about problems they faced while they have been receiving orders and problems regarding delivery of food. The primary problem way in many cases the house or office of customer were far from delivery start point, so it became tough for them to deliver fresh food to customer. After receiving several problems of similar manner, they started using a mechanism of heating the food in the delivery vehicle itself, but it uses battery as a source for heating the food and hence they have to charge the battery in short intervals, change it when its lifetime is over, which has its own drawbacks like more consumption of time and increased cost of delivery, so it is not preferable. As part of the solution to this problem, we particularly focused on induction heating used in heat treatment processes, but we have used this concept of induction heating in heating the food until it is not delivered to the customer. This research paper gives in-depth idea about a device which can keep the food as warm as possible using engine power in a way that it does not affect engine efficiency and also keeps the food warm until it is not delivered to the customers. 1. Introduction. The main and necessary requirement of customers is, they want fresh and warm food when they receive it. The actual problem is that how can companies deliver warm food at any time after baking it? There is a time period of approximately 15 minutes from making food to delivering it at required place, and in this period the food gets cool and sometimes the quality is also diluted. To overcome this problem, initially companies needed to establish more than one center approximate at each and every 6 kilometers distance. Due to which, they had to do a huge investment and face management problems. An alternate and effective solution to this problem is to keep the food as warm as possible until it is not delivered to the customers without using any kind of external battery. Rotational energy of engine shaft is used here to produce electricity by the use of alternator or dynamo, and this electricity is passed through heating coils which is wrapped around the strip placed between main storage box and outer box, which keeps the food warm. Thus it works without utilizing any kind of external source. 3. Market survey. Visits of different food delivery companies like Domino's, Pizza Hut, etc. concluded following information for us. 1. The pizza box is supposed to allow the transport of a baked pizza with the minimum loss in quality possible. To reduce heat flow, the box has to be closed as firmly as possible to keep the warm air inside. Consumers consider a temperature between 70 and 85 degrees Celsius to be ideal for pizza consumption. On the other hand, the box should keep the pizza from getting soggy, so that the crust and the covering are crisp on arrival. To ensure this, the condensation caused by the pizza must be let out, airing holes and some diffusion through the cardboard, or absorbed by the box. 2. There are special padded transport bags and boxes for delivery. Some of these bags can be heated in order to keep the temperature at the desired level. Mostly, they can either be plugged to a socket or powered by the 12-volt car battery. This means that the insulation of pizza boxes themselves is less important. Carry bags insulate best when their lid is connected to the rest of the bag on one side and the remaining 3 sides can be attached to lid by a zip. A bag can contain about 3 to 5 pizza boxes. Required components specifications. Senior No. Component name. Material and specification. 1. Heating coil. Copper, 4 gauge, 7.9 m length. 2. Strip. Iron 15 inch, 25.4 mm dia. 3. Main storage box. Aluminum 606, 15 inch. 4. Outer box. Fiber 24 20 inch. 5. Insulating material. Glass wool 2 inch layer. 6. Support plates. Iron. 7. Connector. 8. Electric wires. Copper. 9. Rectifier. 10. Inverter. 11. Alternator/dynamo. 12V, 55 amp Maruti 800 car alternator. 11. Pulley and belt. Cast iron pulley, fabric belt. 12. Battery. 12V, Exide Explorer, 12XL5LB. 13. Fan. Sun Robotics DC fan, 80x 25mm, 12V. 14. Thermostat. 15. Panel circuit. 4. Components. 1. Heating coil. It is mainly used to heat our main storage box at desired temperature. It is placed inside the outer box and wrapped around strips which are made of ferrous material, so heating is produced inside the core of heating element. 2. Strip. Strips are made of ferrous material like as cast iron which is used as heating coil core. They are placed at outside the main storage box and welded to it. 3. Main storage box. The food is being stored in a main storage box and it gets heated by the heating coils. 4. Outer box. The outer box carries main storage box and heating coils. It also reduces the heat loss. 5. Insulating material. The main function of insulating material i.e. glass wool is to reduce heat loss by convection and radiation. Conduction is negligible. 6. Support plates. The main function of support plates in our product is to support the assembly of main storage box heating coils and outer box. It is able to withstand the load of the assembly. 7. Connector. Connector is used to connect the heating coils with input phase wires which are connected through alternator as input source. 8. Electric wires. The main function of electric wires is to allow the electricity to flow from one device to the other. 9. Rectifier. Rectifier is previously attached to the alternator which is generally used in automobile industries and can be used as converter of current from AC to DC. 10. Inverter. Inverter is a device used for conversion of current from DC to AC current and furthermore it can be used to increase phase current frequency and amplitude. 11. Alternator/dynamo. Alternator is used to produce an electric current by means of conductive material loop cuts the permanent magnetic field and hence produces the phase current. It mainly produces an AC current. Dynamo can be optionally used instead of alternator. 12. Pulley and belt. The main function of the pulley belt drive is to transmit power engine shaft to alternator pulley. 13. Battery. Battery is used to provide startup power to the alternator we have used in our project. 14. Fan. Fan is placed outside the main storage box and is used to maintain air circulation inside the box. 15. Thermostat. Thermostat is used to control the fluctuation of temperature inside the box which is aroused due to the fluctuation of input phase current. 16. Panel circuit. Circuit board used in our project to indicate the temperature state. 5. Design calculation. IMG 20190426WA0008-01. 3D model of storage box. Actual model on delivery vehicle. We have to maintain 70 temperature inside the main storage box with the help of heating coils for maintaining quality of the food. Design calculations for maintaining 70 inside the main storage box. 4. Air. T. Iteration 2. Input power, source power. P equals V asterisk I. V equals voltage of alternator equals 14.4 V at full load condition. I equals current from alternator equals 55 amps, maximum capacity. P equals 14.4 asterisk 55. Equals 792 watts. Dimension calculation of heating coil. Outer diameter of strip on which heating coil is wrapped. Equals 35.4 mm, assume. Perimeter of the strip equals PD. Equals 0.1112 m. Length of the coil/strip equals 0.1112, asterisk 0.381/d. Where d equals diameter of heating coil. We know that P equals I2 asterisk R. 110.3 equals 552 asterisk R. R equals 0.036. We know that R equals resistivity of heating coil material. Iteration 1. We take nichrome as a heating coil material. Nichrome equals 1.1 asterisk 10-6 m. 0.036 equals 6 asterisk 1.1 asterisk 10-642, 0.1112 0.381 d. D equals 21.46 mm. This is a very large diameter of heating coil which is not suitable. Iteration 2. Now, we take copper as a heating coil material. Copper equals 1.72 asterisk 10-8 m. 0.036 equals 6 asterisk 1.72 asterisk 10-842, 0.1112 0.381 d. D equals 5.36 mm. This is quite suitable diameter as compared to nichrome diameter. D equals 5.36 mm equals 4 gauge. So, length of wire/strip equals 0.1112, 0.381/5.3610-3 equals 7.9 m. Total equals 6 asterisk 7.9 m equals 47.42 m. Temperature generated on the strip equals 8961.78 10-4 equals 1.6 kilograms. 33,090.83 equals 1.6385, 1-25. 1 equals temperature generated on the strip. 25 equals surrounding temperature. 1 equals 78.7. 80. Heat loss calculations. Internal convective resistance equals 1H. Calculation of H, heat transfer coefficient. Fan given below is used for proper circulation of hot air inside heating box so that it can be kept warm uniformly, leading to increased efficiency of heating box. Sun Robotics DC fan, 80x 25 mm, 12V. Specification of fan. Length, 40 mm. Width, 40 mm. Thickness, 15 mm. Voltage, 12V. Current, 0.9 amps. RPM, 12,000. Airflow, 14 cfm, cubic feet per minute. Conversion of cfm, image given above shows conversion of unit of airflow from cfm to m/s using online converter 3. From above figure. 14 cfm equals 0.05 m/s, air velocity. Image result for H for air. Graph of H versus air velocity. From graph it is clear that value of H for air equals 22 W/m2K. Internal convective resistance equals 122, 0.381 0.381. Equals 0.313 K/W. Internal conductive resistance in aluminium sheet. 6. Conclusion. After shortlisting certain materials for heating box and coil, calculations were carried out to finalize the materials for same, along with them calculations for temperature generated on strip using this material, for power loss in conduction, convection, and radiation were also done, and here is a summary of all the calculations. Considering extreme conditions of achieving 52 degrees Celsius temperature difference under which this system might have to operate, using aluminium box of 14 gauge thickness is preferable with heating coil having copper as a material. Resistivity of copper is perfectly suitable for this system as diameter calculated based on it satisfies space criterion of this system. Applying all these specifications, temperature generated on strip comes out to be approximately around 80 degrees Celsius along with power loss of 5.32 watt, which is viable for industry requirements.